Welcome back to Generative AI 101, the podcast that makes AI as accessible as your grandma's cookie jar. I'm Emily Laird, your tech-savvy guide. And today we're diving into the core techniques and methods that power natural language processing, or NLP. Grab your curiosity caps, because we're about to explore the nuts and bolts that make our digital assistants, translators, and chatbots tick. Welcome to Generative AI 101. First, let's talk about the rule-based approaches. Imagine you're teaching a computer to understand language using a big book of if-then rules. That's the essence of rule-based natural language processing. These systems rely on handcrafted rules created by linguists and language experts. For example, if you encounter the word bank, the rules help determine if we're talking about a financial institution or the side of a river based on surrounding words. Rule-based systems were among the first attempts at NLP. They're precise and can handle specific tasks well, but are as rigid as a 1950s school teacher. Whoop-pap. That's a ruler hitting your knuckles. They struggle with ambiguity and context because language is naturally messy and fluid. If you've ever tried to explain a joke and found it impossible to capture the humor in rules, you get the idea. Moving on, we enter the era of statistical models. Picture this. Instead of strict rules, we start using mountains of data to let the machines learn patterns. Statistical models leverage large corpora of text to identify probabilities of word sequences. Think of it like teaching a child to speak by exposing them to just a flood of conversations. A classic example here is the N-gram model, which predicts the likelihood of a word based on the previous words in a sequence. It's like guessing the next word in a sentence if you already know the first few. While more flexible than rule-based systems, statistical models can struggle with long dependencies and context. Then came the revolution of machine learning in NLP, and boy, did things get exciting. This is where we teach machines to understand language by feeding them vast amounts of data, letting them figure out the rules themselves. Algorithms like support vector machines, or SVMs, and decision trees became the new kids on the block. Even cooler than the band, right? Machine learning models learn from annotated datasets. Let's take spam detection as an example, right? We train the model on thousands of emails labeled as spam or not spam. Over time, the models learn to identify patterns and features that distinguish spam from legitimate emails. It's like teaching a dog to fetch by showing it countless examples of fetching and not fetching behavior. But we didn't stop there. Enter deep learning in the age of neural networks. Think of deep learning as the machine learning equivalent of going from a bicycle to a sports car. Vroom, vroom, baby. Wheels are hitting the road. Neural networks, particularly those using architectures like long short-term memory, or LSTM, and transformers, have revolutionized natural language processing. Transformers, for instance, enable models to understand the context of words in a sentence by considering their relationship with all other words. This is the magic behind models like BERT and GPT-3. We'll talk about all of that as we continue with this series. They can generate human-like text, translate languages, and even answer questions with an impressive degree of understanding. It's like having a digital Shakespeare who's read every book ever written and can just rifle off any topic. To sum it all up, the journey from rule-based approaches to statistical models and now to machine learning and deep learning showcases the evolution of natural language processing. Each method builds on the last, making our interactions with machines more natural and intuitive. That's all for today's exploration of natural language processing, the core techniques and methods. If you've got questions, thoughts, or just want to connect with me, you can find me on LinkedIn. Just look up Emily Laird, Laird, and let's keep that conversation going. Until next time, stay curious, stay adventurous, and remember, you know more about the nuts and bolts of natural language processing now than you did when you arrived.